Good morning, Honors Algebra 1. It is Thursday, April 9th, and we're going to talk about square roots today. So I wanted to begin by just reviewing how we find a square root with our graphing calculator. We go over here to second, and then we hit the square root key here. And let's take the square root of 225. And we just hit enter, and there it is. We can also take the square root of a decimal number. How about 1.44? And we get 1.2. So just wanted to review that with you real quickly. Let's go ahead now and talk about some things about square roots. So let me push my chair in and push my screen up and pull this in a little bit. Okay. All righty. There we are. I'm going to back this a little bit. Okay. So we're talking about rational square roots today. That means we're going to talk about square roots that will simplify to a rational number. So this is not going to be so bad today. All right. So let's talk about some things we know. We know the square root of 16 is 4. We never say the square root of 16 is negative 4. It's always understood to be a positive 4. Okay, even though negative 4 times negative 4 does give me 16, it's always understood to be the positive number. Now, how would you get a negative answer? If you put a negative sign to the left of the radical sign or the square root sign. So the negative of the root of 9 is negative 3. Now, how about the root of negative 9 itself? Well, that is not a real number, and you don't have to worry about that this year. We'll talk about that next year. Those are imaginary numbers. Now, what about the square root of 0? Well, the square root of 0 is simply 0. Let's go ahead and talk about a special property, the product property of square roots. Now, this is going to really come into play tomorrow when we simplify roots that do not give us a rational square root, but it's good to kind of get an introduction to it today. So it says that if I have the square root of two factors, a times b, that's equal to, you can split it up into the square root of factor A and multiply it by the square root of B. Now let's take an example here. Well, we all know the square root of 100 is 10. But I could break 100 up into two factors, the root of 25 times 4. Same thing as the root of 100, root of 25 times 4. And according to this product property of square roots, I could take these two factors under the radical sign and split them up into the root of 25 times the root of 4. Well, we know that would be the root of 5. The root of 25 is 5. That'd be 5 times 2 is 10. Well, it's the same thing. The root of 100 is 10, and the root of 25 times 4 is 10. Okay, so we can break up these factors under the radical sign, or we call it the radicand. We can break these up into the root of 25 times the root of 4. I'm sorry, the radicand are actually the numbers underneath. This is the radical sign. This is the radicand. All righty. Now, let's talk about a couple other things. The square root of 4 squared is the same thing as the square root of 16. We know that's 4. But I don't even need to do that. If it's 4 squared, the square root of 4 squared is simply going to be the base here, 4. The square root of 25 squared is the same thing as the square root of 25 squared. It's the same thing as the square root of 625, but we can leave it as the square root of 25 squared because we know the answer is 25. The positive value only, remember that. Now, how about the square root of 225? Well, some of you probably remember that when we did mental math last year, that it's 15. But let's break this up into something that's easier. Well, 225 is simply 25 times 9. So we can use our product property of square roots to split that up into the root of 25 times the root of 9, which is 5 times 3, which is 15. I'm in the glare zone. I'm sorry. Okay, so we just are using our product property of square roots to make it a little bit simpler. Now let me step on this side. How about the square root of 2,304? Well, you can actually put that in your calculator the way we just did it a minute ago, and you will find out the answer is 48. But what if I just didn't think, man, is that really what we call a perfect square? Does it have a rational square root? Well, what if I went ahead and did my prime factorization over here? Now I started by knowing this is an even number, so 2 goes into 2304, 2 goes into 1152, 2 goes into 576, 2 goes into 288, and I got up to 144. Well, I know what 144 is. 144 is the perfect square of 12. 12 squared is 144. And then 2 to the 4th power is 16. So I know that this number is 16 times 144. So let's go ahead and put those two perfect squares under the root. And I've got the root of 144 times the root of 16 is, simplify it, 12 times 4 is 48. Now, you don't have to go to all this trouble today, but we're going to be using these principles in our next lesson tomorrow. So it's good to just understand how you can break it down into some factors. And if those factors are perfect squares like that, it's a piece of cake, okay? Now, how about if I have a fraction? What if I have the fraction of, the square root of 100 over 25? Now, I could break that down into the square root of 100 over the square root of 25, which is 10 over 5, which is 2. Or I could reduce this first to 4, and the square root of 4 is 2. Now, why can I do that? I can do that because I have what is called the quotient property of square roots. And the quotient property of square roots, so that I can take a quotient here under the radical sign and split it up. Like we split up the factors under the radical, we can also split up the quotient and make it the square root of A over the square root of B. Now, the square root of 36 over 121 can be split up into the root of 36, which is 6, and the root of 121, which is 11. Now notice that I'm saying the root of 36. I do mean the square root of 36, but mathematicians will just kind of shortcut and just say for square root, they'll say the root. Okay, so if you hear me say the root of 36, I mean the square root. Okay, now what if you see right here a plus minus sign in front of your radical term here? Well, that just means your answer is going to have a positive and negative with it too. Don't be too concerned about that. Just put the plus minus. It means both the positive and negative answers are correct. Now, I'm going to copy my plus minus, and I'm just going to break this down into the root of 144 is 12. Now, how about the root of 3025? Well, I don't really know what that is, but I can certainly use my calculator. It is going to give me the whole number 55. So this simplifies to plus minus 12 over 55. Now, you're going to see things like this on the homework. The negative of the root of 12/75, and you're going to say to me, I can't, what? The square root of 12 over the square root of 75. Square root of 12, I don't know what that is. Well, let me tell you what you always should do before you give up on a problem like this. Always reduce the fraction if you can. Can 12/75 be reduced? Absolutely. Numerator and denominator are divisible by 3. So let's go ahead and do that. Divide 12 by 3, I get 4. Divide 75 by 3, I get 25. And lo and behold, look at these beautiful perfect squares. And so my answer is going to be the negative square root of 4, which is 2, over the square root of 25, which is 5. And I have negative 2/5. So for this lesson, get those calculators out and let those calculators help you find these square roots, because all of these square roots, after you reduce fractions and on all the other problems, will give you whole numbers. Okay, so come to the Zoom meeting at 11. If you've done the homework and you're having some issues with it, remember the password is now required. It's on the class wall, and the ID for the meeting has stayed the same. It's always the same, and I'll be here at 11 o'clock. So I hope you have a great day, and this homework is not due until Monday. Yes, because we have a 3-day weekend, and tomorrow is Good Friday. So if I don't see you at the Zoom meeting, I hope you have a wonderful Easter with your family. I know it's going to be a little bit different. It's so hard not to be in a church at Easter to rejoice, isn't it? But we're doing the best we can, and we're blessed to have family. So y'all have a great 3-day weekend, and I'll see you at 11 this morning or on Monday. Bye-bye.